So now that I've talked to you about what a mole is and how to find the molar mass of an individual element on the periodic table, the next thing I want to do is combine that with chemical formulas. So I'm going to find the molar mass of copper 2 nitrate. So the first thing I'm going to have to do is turn this into a formula. So if I look at my trusty formula sheet and I look up copper 2, I see that it's Cu and it has a charge of +2. And then nitrate is NO3. So nitrate is made up of 1 nitrogen and 3 oxygens. And it has a charge of -1. So in my formula, I'm going to need 2 nitrates to go with my copper if I'm going to end up with a total charge of 0. So that means I have to make sure I put my nitrate, my NO3, into parentheses. And then to show that I've got 2 of everything inside there, I put my little 2 after the parentheses. The next thing I want to do is a particle diagram. So where I'm showing each of the individual atoms that make up a copper 2 nitrate. Now, even though we're starting to think in terms of moles, these ratios are the same. So if you have a mole of copper nitrate, that mole of copper nitrate is made up of 1 mole of copper and 2 moles of nitrate. I can also think of it as being made up of 1 mole of copper, 2 moles of nitrogen, and 6 moles of oxygen. And that way of thinking is going to be really important for molar mass. So what I'm going to do next is I'm going to find how much mass each of these are accounting for. So I have just 1 mole of copper. So I'm going to do 1 times, and then I'm going to switch to my periodic table. And I've got it zoomed in here to make it a little easier to read. I'm going to find copper, and I'm going to look at this number along the bottom of its box. So copper is 63.546. So each mole of copper is 63.546 grams. So that means, if I do 1 times this mass, I will get how many grams of copper are in 1 mole of this copper 2 nitrate. Now for the nitrogen, there's 2 of those, so I'm going to do 2 times that. So I go back to my periodic table. Now I find nitrogen. Nitrogen's up here, and its mass is 14.007. So I'm going to do 2 times 14.007 grams, which is 28.014 grams. And then, last but not least, I'm going to get my oxygen. So there are 6 oxygens here. I'll go back to my periodic table. Oxygen is 15.999. And so if I go back to where I'm doing my math, I have 6 times that 15.999 grams. And when I punch that into my calculator, that is 95.994 grams. So this is how much mass I have of oxygen in 1 mole of copper 2 nitrate. This is how many grams of nitrogen and how many grams of copper. So if I want to know the molar mass of copper nitrate, I'm going to just add these numbers together. So I'll do the mass of copper that I have plus the mass of nitrogen that I have. And, oh, there we go. And then I'll also add to that the mass of oxygen that I have. So I'm adding these three numbers from above together. And it's kind of like in the intro activity you did, where, for example, if you had 2 bolts and 1 washer, you would do 2 times the mass of a bolt plus the mass of a washer. We're doing something very, very similar here. And when I put all of that in, I get 187.464 grams. So that's going to be the molar mass of a copper 2 nitrate. So that means whenever I have 1 mole of copper 2 nitrate, if I were to put that on a balance or a scale, that scale would read 187.464 grams. Now, a lot of the problems you're going to do are going to read something like this. How many moles of copper 2 nitrate are in 300 grams? So what that means is if I'm in the lab, I have a pile of this stuff sitting on my balance. If I have 300 grams, I know from the work we just did that each copper nitrate, or rather each mole of copper 2 nitrate is this 187.464 grams. So the number of moles is going to equal the mass that I have divided by the mass of each one. So I'm going to do 300 grams divided by this molar mass, that 187.464 grams. And my calculator gives me a fair number of decimals. You don't need to give every single decimal from the calculator. I'm not going to be picky about exactly how many. But it gives me about 1.6. So that means I have 1.6 moles. And it is possible to have part of a mole. So just like you can get a half dozen eggs or a full dozen eggs, you can have part of a mole. It just means you don't have enough atoms to make up that full mole.